Alright, let's start with basic navigation. Firstly, the shape of the Earth. As you can see, the Earth here is slightly flattened at the poles and slightly broader at the equator. So we know the Earth is not a perfect sphere, it's actually an oblate spheroid. Oops. It's actually an oblate spheroid, or it can also be called an ellipsoid. It's not a perfect sphere. Now the polar diameter, which is between North and South Pole, is 6865 nautical miles, and the equatorial diameter between these 2 points is 6888 nautical miles. Now, because of the fact that the Earth is flattened at the poles, there's compression, which gives rise to a formula for compression ratio. So the compression ratio of the Earth is 0.3%. The formula for which is equatorial diameter minus polar diameter upon equatorial diameter, which gives you the compression ratio. It's important to remember this formula because they can give you a model of another planet which they'll call Earth, but these values will be changed. So you'll have to apply this formula to find out the compression ratio of that particular model or planet. Applying these values into this formula, the equatorial diameter 6888 minus the polar diameter 6865 upon the equatorial diameter 6888 gives us the compression ratio, which is 1 by 297 to be precise, roughly 0.3%. This is the compression ratio. Now, looking at these two numbers, we can also see that the polar diameter is smaller than the equatorial diameter by approximately 43 by, no, that's kilometers. So the nautical mile difference between these two is about 23 nautical miles, 43 kilometers, and statute miles 27 statute miles. But you won't have to remember this value and this value. As long as you remember this, it's fine. Imaginary lines on the surface of the Earth are called latitudes and longitudes. These help us navigate by allowing us to accurately define a particular address for a location. For example, this location right here, it may be, for example, 10 degrees north longitude and say 15 degrees west latitude. This allows us to pinpoint the accurate location of this place down to meters. I mean, of course, we'll have minutes here. Why do I do this? Latitudes and longitudes are imaginary lines on the surface of the Earth which help us navigate and accurately define the address of a particular location on the globe. A longitude is basically an imaginary line that runs from the North Pole to the South Pole. It is a semi-great circle. What is a semi-great circle, you ask? We'll get to that in a minute, but it's a semi-great circle for now with imaginary lines running from the North Pole to the South Pole. Latitudes are basically rhumb lines, we'll get to that in a second as well, that run from the prime meridian all the way across the world, which will go somewhere like this and back. But for our purposes right now, 1 second. Yep. Basically, this is a, oops, what have I done? This is a parallel of latitude, and the vertical line is a longitude or a meridian. Alright, so here we have the definitions of longitude, latitude, GC, and rhumb line. A longitude is a semi-great circle running from the North Pole to the South Pole, whereas a latitude, a parallel of latitude, is a small circle whose planes are parallel to the equator. What is a GC and a small circle? A GC is basically the shortest path on the Earth. Basically, if we're flying the shortest distance from A to B, we'll be flying a GC track. The definition of GC is great circle is basically the largest possible circle that divides the Earth into two equal halves. The equator, for example, is a great circle because it divides the Earth into the northern hemisphere and the southern hemisphere. The prime meridian as well as the anti-meridian of the prime meridian is a great circle because it divides the Earth into two equal halves again, the eastern hemisphere and the western hemisphere. A great circle has the same radius as the Earth as well as the same center as the Earth. As I said, it is the shortest distance between two locations on the Earth. And unless two points are diametrically opposite, so unless one point is here and the other here, there can only be one GC drawn through it. If you follow any radio navigation aid such as VOR, the radials follow a GC path. Rhumb lines, on the other hand, are lines which are curved on the surface of the Earth, and they cut each meridian at the same angle. Rhumb lines have constant true direction and they spiral towards the poles. And rhumb line distance is greater than GC distance because GC is the shortest path on the Earth. An important point to remember, the equator, which is this line right here, is a great circle as well as an RL or a rhumb line. Great circle because it divides the Earth into two equal halves and has the same radius and center as that of the Earth. And a rhumb line because it maintains a constant true direction and cuts all of the meridians at an equal angle perpendicularly, that is. So this is perpendicular, this here is perpendicular, this here is perpendicular. And I mentioned small circles to define a latitude, a parallel of latitude. Small circles are basically circles on the surface of the Earth which could not divide it into two equal halves. So they do not share the same radius or the center as that of the Earth. So an important point to remember is that every parallel of latitude except the equator is a small circle, but every small circle is not a parallel of latitude. So believe me, all three of these angles, even though this one seems slightly bigger, are 1 minute in dimension. The arc it makes on the surface for 45 degrees north and south is 1852 meters. For the equator, at the equator, the arc made is 1843 meters. And at the poles, it's greater at 1862 meters. This is because of the shape of the Earth. Since it's flattened at the poles, the arc of one angle subtends to a larger distance. But for ease of calculation and convenience, instead of constantly finding which dimension to use for what location, we've decided to consider the average, which is roughly 45 degrees latitude, as the measurement for a nautical mile, which is 1852 meters. Right, that's the definition. Now moving on to 1 kilometer. 1 kilometer is very simply defined as 1 by 10,000th of the distance between the equator and either pole and pole. This basically means that the distance between the equator and the pole is roughly 10,000 kilometers. So 1 by 10,000th of the distance would give you 1 kilometer. It's a very simple definition to memorize. Also, one more conversion we should keep in mind is 1 nautical mile is roughly 6080 feet, and 1 kilometer is roughly 3280 feet. This is important. It's used in numericals throughout radio and GenNav. So I've drawn two diagrams here to highlight the difference between geodatic and geocentric latitude. Geodatic is also called geographic at times, but geodatic is the name we use more often. Geodatic latitude is the angle between the normal of the observer's plane and the horizontal plane of the Earth, and the equatorial plane rather, of the Earth. So if you drop down directly perpendicularly from where the observer is standing till you reach the equatorial axis or the equatorial plane, the angle made between those two positions will be the geodatic latitude. So at 45 degrees north and south, that angle is found to be 45 degrees 11.6 minutes. Now if we talk about geocentric latitude, that's the angle that is made between the line joining the observer to the center of the Earth and the equatorial axis. That's 45 degrees at 45 degrees north and south. So the maximum difference is found at this latitude. That's due to the compression of the Earth, which is 11.6 minutes. Now, because this difference is so minute and negligible, we do not consider it at all. That's why we use only geocentric for our calculations and not geodatic, because the difference is so minor due to the compression ratio being only 0.3% as discussed earlier. So moving on to the numericals of basic navigation, one very basic type of numerical is finding out the difference between two latitudes or two longitudes on the Earth. She lat stands for change in latitude and she long stands for change in longitude. One very basic rule that applies to both of these is same sign, subtract, and opposite sign, add. Basically, if both of the locations are in the northern hemisphere or both are in the southern hemisphere, then you'd subtract the two values amongst themselves to find out the she lat, which is the difference in the two latitudes. But if they're in the opposite hemisphere, so if it's north south or south north in the question, then you'd add the two values to find out what the change in latitude is. We'll do a couple of examples. So if I am to find out the change in latitude between say 40 degrees south and 50 degrees south, since they're the same sign, I would subtract. So 50 minus 40 would give me 10 degrees, which is the change in latitude. If I were to find out the difference between 10 degrees north and say 50 degrees south, then I would add these two values. My change in latitude would now be 60 degrees. And if I'm moving to the south, that's 60 degrees south. If I'm moving to the south, that's 10 degrees south as well. Now the same rule applies for Shillong, which is change of longitude as well, with an added rule. If the sum of both the longitudes rather, is 180 degrees, then it is a back of the earth case. Back of earth. I'll explain what this is in a minute, but we'll first do a couple of examples for same sign and opposite sign. So if I am to find out the Shillong between 10 degrees east and 30 degrees east, the movement is 20 degrees to the east. Since they are the same sign, I have subtracted these two values. If I am to find the difference between 10 degrees east and 30 degrees west now, I'd add these two values and this will be 40 degrees, and since I'm moving from the east to the west, my direction of motion will be west. Alright, so these two diagrams will help us distinguish between front of the earth questions and back of the earth questions. Basically, if the sum of the two longitudes, as I mentioned earlier, is 180 degrees, then it's a back of the earth question. Or if the values are greater than, for example, 150 on either side, then you'd rather go from the back than from the front because it's a shorter route. So for example, if I am to go from 160 west to 160 east, I will have to travel this way first, which is towards the east, get to 180 degrees east-west, which is this longitude, and then travel 20 degrees rather, more to the east to reach 160 degrees east. So my total travel would be 20 degrees initially to the east, then 20 degrees more, which would be 40 degrees east, my Shillong. Instead of going around the front and then, that'll be a long route. So I'll take the short route and I will again, due to the signs being opposite, one is in the west and one is in the east, I would add these two values. Now it's important to mention this is the anti-meridian of the prime meridian. And in the front, this is the prime meridian, which passes through Greenwich in the United Kingdom. Also an important point, Greenwich in United Kingdom. Prime meridian divides the earth into two hemispheres, east and west, and the equator divides it into two hemispheres, north and south.